Welcome back once again, great minds. So, as promised, we're looking at the 3 advanced products, and this is generally your exam instruction: expand and simplify. Simplify just means get rid of all the brackets and add the like terms. Okay, there's some things that we need to follow here. I'm actually going to put them underneath each other. We need to still follow oddness. We need to still use SNV, again with variables using our exponential laws. Okay, so let's have a look at how it works in practice. I'm going to drop the colors now and we're going to do this straightforward. So we've got 3 times a bracket being squared. So by BODMAS, the bracket has to be dealt with first. There is an operation in the bracket, but 3x plus 2, there's nothing you can do. You don't know what x is, so we can't do anything there. So next up comes the power. Just like in our last example, I'm going to leave the 3 here. I'm going to make a bracket. Let's actually make it a square bracket to stick to the etiquette. Remember, when squaring a binomial, we are actually just multiplying the bracket by itself twice. Okay, which means we are going to FOIL. I'll draw my arrows in. And this 3 stays on the outside. Okay, it is going to eliminate the round bracket, so the square ones can become round now. You can also leave it square. But in any case, 3x times 3x gives me 9x squared. My outers, 3x times 2 gives me a positive 6x. 2 times 3x gives me a positive 6x. And 2 times 2 gives me 4. Again, I don't want you to worry about the 3 yet. First, clean up inside the bracket. Add those like terms. 3 stays. 9x squared stays. 6x plus 6x is 12x. And the plus 4 stays. Now we get to a point where we can deal with the 3. The 3 is actually just going to be used as multiplying a trinomial by a binomial, so distribute it. 3 times 9 is 27 x squared, plus 3 times 12 is 56 x, plus 3 times 4 is 12. And then that is our final answer. There are no extra like terms, there's nothing, no brackets left, that's all we can do. Okay, we've got 2 more. They do get progressively more complicated. Oops, brackets stay behind. Okay, let's make a decent amount of space for this one. We've got a half, 2x plus 4, 2x minus 4, minus x minus 3 being squared. Again, we have not looked at the shortcuts for these yet. I need you to notice again that these 2 are the same, just the middle term differs, and here we've got a bracket being squared again. So the very first thing I'm going to do is, again, this half is going to stay here. There's nothing that's going to happen to it, but I am going to FOIL this out properly. And this I'm going to rewrite as 2 brackets. Okay, so I'm going to do that in one step. Half stays, bracket stays, 2x times 2x is 4x squared, 2x times a negative 4 gives me negative 8x, positive 4 times 2x is positive 8x, positive 4 times a negative 4 is negative 16, and close that bracket. This negative stays, and I'm going to make this into 2 brackets. Which means here I'm going to FOIL properly as well. And over here we've got like terms. So the half stays, the 4x squared stays, plus minus 8x plus 8x cancels out. So just the minus 16 stays. This negative stays. I'm going to leave, and I'm going to make a big circle here for this negative. It means that negative is going to affect the answer from this multiplication. This is still a negative 1 technically being multiplied by that entire answer. So the answer here I'm going to leave in brackets because I still need to multiply that by the negative. So foiling here, x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Again, before I do anything else, I'm first going to clean up inside that bracket. I can distribute this half now already. You can also wait for the next step. 4 times a half is going to give me 2x squared. Positive times a negative is a negative. 16 times a half gives me 8. Negative stays. X squared stays. Minus 3 is minus 6x plus 9. And now this negative needs to distribute. So the 2x squared stays. Minus 8 stays. Now this becomes a negative x squared. Negative times a negative gives me a positive 6x. And a negative times a positive gives me a negative 9. And now we've got more than one type of like term. So let's get some color here. There's x squared. There's no normal x's, there's just one, so there's no more than one, but there are also two constants. So those are all the like terms. I've got 2x squared minus x squared, which is just going to be 1x squared. You can write 1x squared, or you can leave it as x squared. I'm going to put the 6x next. Again, that's just an etiquette thing. And then minus 8 minus 9 is minus 17. And that is the final answer here. As always, grade 9s, you can test any of these answers. I will show you with this one just now how you would test it, just after we finish number 3. Now, number 3 is something I just need you to take note of, that a half x means the same as x over 2, which also means that 3 or x over 3 is the same as a third x. You can split them apart or write them together. It's up to you. Okay, this was just done, I don't want to say on purpose, but kind of on purpose. The easiest option generally is to put it together. So I'm going to do that with the first one. And I'm going to write it as x over 2 minus 1. And I'll leave this as x over 3 minus 3. Still binomials, they still need to be multiplied. So firsts, outers, inners, lasts. Now, x over 2 times x over 3. Multiplying fractions, we multiply the numerators and multiply the denominators. So x times x gives me x squared. 2 times 3 gives me 6. Right. X over 2 times a negative 3. If you multiply a whole number by a fraction, you just multiply the numerator by that. So positive times negative is negative. 3 times x is 3x, and that will still be all over 2. Negative 1 times x over 3. Negative times a positive is a negative. 1 times x is just x, and it will be over 3. And lastly, a negative times a negative is a positive. 1 times 3 is 3. Now, here's where the problem comes. These are like terms. Okay, they have the same variables with the same powers for each. But now you're dealing with fractions. So what do you know about fractions? If you want to add or subtract them, they must have the same denominators. So we need to change the denominators here. LCD between 2 and 3 would be 6. So I would have to multiply this one by 3 top and bottom, and this one by 2 top and bottom. So in actual fact, what am I left with? X squared over 6 minus 3 times 3 is 9x over 6 minus x times 2 is 2x over 6 plus 3. Now they have the same denominators, so we can add them. X squared over 6 minus 9x minus another 2x is minus 11x over 6. And the plus 3 stays. Now, there are other things you can do here. You can simplify it further and make it one fraction, but this would be completely fine for a final answer. If you want to make it one fraction, you need to remember that this 3, I'm going to do it here on the side to just show you. This 3 is technically over 1, which means if I want to get it over 6, I need to multiply by 6, top and bottom, meaning that I'll be left with x squared over 6 minus 11x over 6 plus 3 times 6 is 18 over 6. And once everything is on the same denominator, we can write it on one denominator. So x squared minus 11x plus 18 all over 6. Okay, so that is the same as this. This is just a more simplified form, but this is perfectly fine. Okay, but now we are going to quickly look at just how you would test it. Just the same as how we tested in our exponents chapter. Any algebraic expression, an equation is easy to test because you have an answer. An expression is just as easy to test. Just pick a value for x and y again, stay away from zeros, ones, negative ones, and make sure your answer here and your answer here matches up. So I'm going to take this one, I'm going to copy it, I'm going to move it to a completely separate page. I'm going to get rid of all the working in between because that's not necessary for us right now. We just want to test this. So in testing this, I just need to make sure that if I pick a value for x, or for all the variables, in this case it's just x, and I apply it straight through, so let's say x is 3. Again, don't go too big, because otherwise you end up with massive numbers. So I'm going to start here. This is the quickest one to work with. I'm just going to grab my calculator, and I'm going to substitute 3 into the place of x. And that's going to give me 10. And I'm just going to make note of that. And then I'm going to retype all of this, again, replacing the x's with 3. So I've got a half times 2 times 3 for the x plus 4. Open the bracket, 2 times 3 minus 4, close the bracket, negative, open the bracket, x is 3, so put that in its own bracket, minus 3, and that's all going to be squared. And there we go. We also get to 10. So if these two answers match, you know you've simplified correctly, because the goal of simplification is to not change the value of the expression. So these two things are exactly the same, because if I substitute a variable there, I get the same value. So I have not changed them, I've just made it simpler. Yeah. So that is it for the more advanced products. We are going to look at exercise 1 and exercise 3 in class. And let me just see something quickly. Functions. Why is this only up to February? I need to find March and see if we have. Oh, there's March. Perfect. More advanced products, and then we go to fractions, and then we come back to factorization. That's silly. Okay, so As you can see, there is notes here on factorization. Like I said, this is the end of term 1 work, technically. Factorization is the opposite of simplification. So if I go back to this, to foiling, if I give you this, or not, that's a bad example. Let's say if I give you this, you need to be able to get back to that. So it's going in reverse. But that we look at after we have a quick look at your fractions chapter. As you can see, it's just revision of common fractions in algebra and basic things with regards to fractions, and then we come right back to factorization, doing all the different types of factorization. Okay?